Hey guys, I'm going to start doing talking about chapter 10.3. So let's go look at that. So, alright. So remember in 10.2 we were doing hypothesis testing, but we were doing it for population means, but the standard deviation was known. Here it's not known. So the objective was to use the rejection region to draw a conclusion, or to use the p-value to draw a conclusion. All right. When the population standard deviation is unknown, the sample taken is a simple random sample, and either the sample size is at least 30 or the population distribution is approximately normal. The test statistic for a hypothesis test for a population mean is given by t equals the sample mean minus the population mean divided by the sample standard deviation divided by the square root of n, which is the sample size. This looks a lot like the z-value. So in a hypothesis testing for a population mean, where the population standard deviation is not known, the number of degrees of freedom for the student t distribution of the student statistics given by df equals n minus 1, where n is the sample size. So the degrees of freedom equals n minus 1. So if our sample size was 20, our degrees of freedom would be 19, because 20 minus 1. Rejection rules for the hypothesis test for population mean, where the standard deviation is unknown. You're going to reject the null if t is less than or equal to negative t alpha for a left-tailed test, t is greater than or equal to t alpha for a right-tailed test, or the absolute value of t is greater than or equal to t alpha divided by 2 for a two-tailed test. All right, so we're using the t-table that we used in 8.2. So we did that, and now we're going to actually go ahead and use those t-values we looked up. Find the critical t-score, which corresponds with 14 degrees of freedom at the 0.025 level of significance for a right-tailed hypothesis test. Okay, so we're scanning through the table. We see that the row for 14 degrees of freedom and the column for a one-tailed area where this level of significance is 0.025 intersects at a critical t-score of 2.145. Hence, t alpha equals 2.145. Okay, and we see that now. Again, we're in the area of one tail, so the alpha is 0.025, and the degrees of freedom are 14. So let's do an actual problem. Nurses in a large teaching hospital have complained for many years that they are overworked and understaffed. The consensus among the nursing staff is that the mean number of patients per nurse each shift is at least 8. The hospital administration claims that the mean is lower than 8. In order to prove their point to the nursing staff, the administration gathered information from a simple random sample of 19 nurses' shifts. The sample mean is 7.5 patients per nurse with a standard deviation of 1.1. Test the administrator's claim using a significance level of 0.025 and assume that the number of patients per nurse has a normal distribution. All right, so now first thing we have to do is state the null and alternative hypothesis. So the researchers are gathering information about the mean number of patients per nurse. So we're going to test that the alternative is the mean is less than 8, because that's what the hospital administrators believe. The null hypothesis is the mean is greater than or equal to 8. So now we're going to determine the test statistic and state the level of significance. So we know the level of significance is 0.025. And now what we're going to do is we're going to calculate that t-value. So if you plug everything in for the t-test statistic, you get negative 1.981. Remember, 7.5 was the sample mean, 8.0 was the population mean, which we're testing in the hypothesis, 1.1 was the sample standard deviation, and 19 was the sample size of nurses' shift they looked at. Okay, so All right, we're going to draw a conclusion and interpret the results. Next, notice the symbol found in the alternative hypothesis that we are running for our left-tailed test. Then we need to obtain the critical t-score for the rejected region. From the table, we'll see that a one-tailed test with a significant level of 0.025 and n-1 is 18 degrees of freedom has a critical score of 2.101. But because the area is a left-tailed test, shaded in the left tail of the distribution, remember, we add a negative sign to the 2.101. So the rejection region shown in the following graph. Because the test statistic calculated for the sample, t is negative 1.981, it does not fall in the rejection region, we must fail to reject the null. So if we look at it here, because negative 2.101 is smaller than negative 1.981. So because of that, we failed to reject the null. So what can we say? We can interpret the conclusion to mean that the evidence collected is not strong enough at the 0.025 level of significance to reject the null in favor of the administrator's claim that the mean number of patients per nurse is less than 8.0. So that means the nurses have a case in this point. Okay, so we can use the p-value, and I'm going to use that in the next video.